Hi, today we're going to do lesson 12 for inscribed angles. So, an inscribed angle is where the vertex is moved from the center to on the circle. Now, circles technically don't have like sides. So, we call it like when it's touching the outside of the circle here, like the black part, we call that on the circle. Okay. Um, so, it's all about the placement of the vertex. So, in our last lesson, the vertex was here at the center, like this. And for a quick review, that is called central. So when it's the central angle, the measurement here is the same as the arc, right? Now today, inscribed will change. Okay, an inscribed angle is equal to half of its intercepted arc. Okay, so if this is 100 degrees out here, then we know this was 100 because that's what we did last time, but it's going to be half of that. And so the little angle back there is being stretched and it's now 50 degrees. So it's half the measure. Inscribed angles that intercept the same arc are equal. Of course. Okay, so if this is, oh my, if this is 30 degrees and you have this angle here, that means this is half of it, so it's 15. Well, this angle here opens up to the same arc that is 30, so that means this is also not 30, it is 15. It is half the measurement according to theorem 63. So if they open up to the same arc, they're going to have the same measurements. Okay, that's kind of common sense. An angle inscribed in a semicircle is a right angle. Okay, so we know a semicircle is 180 degrees, correct? Now, if you open it up, like, and it's inscribed into a semicircle, like this was 180 as well. Let's go this direction. We know all of this is 180. So half of 180 is 90. So we know that angle is 90. So it's just kind of easy just to remember. If you can tell the angle's opening up to a diameter, then you know it's a right angle. According to corollary 2. Make sure you don't just say corollary 2. You have to say theorem 63 corollary 2 or theorem 63 corollary 1 because there's lots of corollary ones and we have to know which one you're referencing. Okay, so we're just going to practice some of these. And in order to do this first one, when I say first one, I mean this one. And I have a 5-minute time limit. So if it runs out, I'll make a part 2 of the video. I'm going to find this angle. And so it's a triangle. So let's take 180 and subtract these two angles. So 180 minus 49 minus 70 is 61. Now, technically, this is an inscribed angle. The vertex is on the circle. So I'm going to take the 61 and double it to get up here. So 61 times 2. 61 times 2 is 122. Yes, I think. All right. So, yes, there are other ways to do it, but to me, that was the quickest. All right, next one. Where's the question mark? Oh, it's on here. So how do you get this? Now, first thing I notice is the angle W opens up to a diameter. So that means this is 90 degrees. But really, we don't even need that. Okay, we don't need it. What I'm noticing here is that this opens up to this arc. So I'm going to take 42 and times it by 2 to get 84 to get this arc length. And then we're done. All right, and some of them do get much more difficult. And this one here, it's like, where's 35 even go? We're going to say that 35 goes here. All right, so that is inscribed, right? And so if I double that, that means I know this arc, which is 70. Now this is a diameter, and so that means all of this is 180. That looks horrible. Hopefully you can read that. So what I'm going to do is I'm going to take the 180 and subtract the 70, and I'm left with 110. That's a 10. And that is the measurement of the question mark. And if I remember right, this